We're going to start chapter 1. Okay? I'm going to cover 1, 2, 3, and 4. I was going to give you a worksheet today on 5.1 and 5.2, but I didn't really get far enough, so I didn't give it to anybody. All right? So I'll probably work some more problems tomorrow, and then I may give you your worksheet. I will definitely give it to you tomorrow, but I want you to have some in-class time to work on the worksheet, because the worksheet is difficult. Okay?
Yeah, why is this green?
So, let's see. I'll see if I can fix it. I'm such a technical person. I'll probably get electrocuted. If I do, hit me with a big board or something. Shock yourself.
I hope you not seen this picture because
Why you don't
like
grab?
No,
Because then you'll just like
no.
that. Because you'll automatically bend backwards like that, because if you don't, you'll like shock it, you'll grab onto it, and you'll be like, oh, no.
Yeah, I want to put like something on the side.
Okay, we'll just pretend like it's not doing it. I'll try. Like it is.
Funny.
I bet that's it. Is that better? No? Okay. We won't worry. All right, so properties of exponents. All right, your test will be over 5.1 through 5.4. Listen to me. The problems on the worksheet are really difficult. Okay, will the problems on the test be that hard? Where can I find problems to study on for the test? In the textbook. No, in the
What did
textbook.
you say that day? You said the big thing that's paper bounded together by a sponge. You got real mad that day.
You are crazy, like just sitting there. So here we go. There are 7 properties of exponents, okay? We're going to make us a big old chart, okay? On the left-hand side, we're going to do the property name, which is really kind of useless, but whatever. Do I have to know the property name to be able to use it? No. No, I don't. Okay? But anyway, it's gonna take off the whole page. All right, the second space is going to be for what they call the definition of the property. All right? I think probably a better word is, this is the rule that you will follow. Okay? So the property it's a rule, and so that's the rule that you're gonna follow. And then the last one, I'm going to make it even big. I'm going to make it bigger. So I'm going to. The last one's going to take up a lot of room, so I don't need that much room on this guy, so I'll move him over. The last one we're going to put examples. Okay, examples. And I'm even going to be so nice as to, in a different color, can y'all tell that's a different color? Yes. Blue. I'm going to put examples for careless mistakes. So at first you're kind of going, what? But when I show you this stuff, these skills, they lend themselves for kids making lots of careless mistakes. I tell you how to do something and then you can do it one way, but if I write it a different way, y'all mess it up. So I want to show you what might happen. So the very first one is going to be, how do you multiply exponents? Okay, multiply exponents. So this is what it looks like. If I have a to the m times a to the n, okay? A to the m times a to the n. Now, notice what has to be true. What's this thing down here called? I know it's an a, but what's it called with respect to this power? It's a base, yeah. And notice that my bases have to be the same. If your bases are not the same, you cannot use this rule, okay? The bases have to be the same. So what's the rule? The rule says that you take the base. What's the base? A. And you add the exponents. Okay? What did I tell you to do? Take the base and add the exponents. All right, everybody got it? Okay, so let's work some examples. So here's the first one. This seems very easy. Do you agree? Like, for instance, what if I had x x to the second times x to the third. What would that be equal to? Yeah. 2, got the same base, so I take the base and I add my exponents. 2 plus 3 is 5. Huh?
We did this part in chemistry.
Oh, very good. Okay, there's another way to look at it. There's 2 x's here, right? X times x times x times x times x. So how many x's do you have? Well, you got 2 here and 3 here, so you got 5 altogether. All right, now let's make it a little more difficult. What if I have one like this? 2ab to the second, c to the fifth, times 3a squared, b to the fourth, c. Okay, so we're going to do this kind of like you eat an elephant. Do you eat an elephant all in one bite? No, just a piece at a time. Okay, kind of like you clean your room up, right? When your mom says clean your room up, you go in there, and the first thing you do is you clean off your bed. So you have a place to start, right? And then you clean out from under your bed, where she told you to clean up earlier, and you shoved everything under there. Okay, so just a piece at a time. So this is a multiplication problem, guys, a piece at a time. What is 2 times 3?
6. I'm
Yeah.
sorry, I didn't know.
6, all right? Now look, here's something that lends itself to mistakes. So this is what I tell kids. If something doesn't have an exponent, let's put an exponent there, okay? What is this a? What power is he raised to?
1.
The first. So we can put a 1 there. You see anybody else who needs a 1? The c. Okay? Now when we're multiplying, what are we doing with my exponents? You're adding them. Okay, so what's a to the first times a to the second? Very good. What's b to the second times b to the fourth? What's c to the fifth times c to the first? Was that hard? That was really easy, wasn't it? Okay, so now I'm going to give you one to work by yourself. Are you ready? Notice what pen I brought out. See my pen? What am I telling you?
Oh, I don't know.
Example.
2 to the third times 2 to the second. People, if you only could follow the rules. Let's see who can follow the rules. All right, you got it? What's your answer? Very good. 2 to the fifth. What's the careless mistake? Yeah, to go 2 times 2 is 4. People, did they go a times a is a squared? No. Take the base and add the exponents. So, take the base and add the exponent. If I put a letter there, a variable, nobody ever makes the mistake. But as soon as I put a number there, they change all the rules. Don't change the rules, guys. Take the base and add your exponents. Look, you have 3 2's here and 2 2's here. How many 2's do you have? You don't have any 4's, do you? You have 2's, 5 2's. Everybody got it? Okay, so here we go. Here's number 2. Number 2 is a power to a power. Power to power. All right, this one's pretty easy. If you have a power, which is just a base and an exponent, and then I raise it to another power. All right? Powers to powers, you multiply your exponents. So it's going to be a to the m times n. You get it? Okay, so let's try some. I'm just going to do 2. X to the fourth raised to the second. X to the fourth raised to the second. What is it? X to the 8th. Okay? Now, watch. Y'all, I told you there are 7 of these, right? So let me tell you kind of what's going to happen. I'm going to show you a way to keep it from happening. I'll show you a little trick that you can do. But here's the deal. These seem fairly easy, right? But watch what happens when I start mixing these things all up together. Watch what happens to your brain. When you multiply, you add your exponents. Powers to powers, you multiply your exponents. When you divide, guess what you're going to do with your exponents? Subtract them. Do you see what I'm saying? It gets kind of confusing because you're mixing it all up. But I'll show you a way to keep it straight. All right, so here we go. 2 to the third raised to the second. 2 to the third raised to the second. What's my answer? 2 to the 6. 2 to the 6. All right, so here's the next one. This is number 3. This is power of a product. What does product mean? You're multiplying. Okay? So what you have is you have two things that are multiplied together and they're both raised to a power. Okay? Well, it's very logical what you do. It just means that everybody in these parentheses gets raised to that power, right? Yeah. A to the m, b to the m. All right, you with me? Okay, so, let's see, let's do one. A squared, b, c to the 4th, all raised to the 3rd. A squared, b, c to the 4th, all raised to the 3rd. Powers to powers, what do you do with your exponents? You multiply them. If you need to and it helps you, you can put ones where they don't have ones. Okay, sometimes that helps kids. Mostly it helps them when they're adding and stuff because they don't see them. All right, but powers to powers, you multiply your exponents. What's a to the 2nd raised to the 3rd? Very good. What's b to the 1st raised to the 3rd? Pardon me. What's c to the 4th raised to the 3rd? Very good. All right, anybody got a question? Okay, so, look what I got. Got my blue pen. We're fixing to see who makes a careless mistake. 2xy to the 5th, all raised to the 3rd. 2xy to the 5th, all raised to the 3rd. Okay, you ready? What'd you get for your answer?
2x,
Garrison got it right, okay? So here's the common mistake. The common mistake is you're all focused on these right here and you forget this guy gets raised to the power 2. Okay? He's a coefficient. 2 to the 3rd is what? 8. There's a 1. X to the 1st raised to the 3rd is x to the 3rd. Y to the 5th raised to the 3rd is y to the 15th. Okay? Another way that you could think about that is if you thought about it like this. 2 to the 1st, x to the 1st, y to the 5th, all raised to the 3rd. So then it becomes 2 to the 3rd, x to the 3rd, y to the 15th, and this is an 8. Okay? If it's reasonable, I want you to do it. You understand? If it's reasonable, I want you to do it. Y'all, if that's a 2 to the 10th, would I want you to do it? No, people, we don't know. 2 to the 10th is some big, long number. Okay? I don't know what it is. All right? I'd have to pull my calculator out or take 5 minutes and figure it out. All right, so here's the next one. This is number 4. Number 4 is negative exponents. Okay, negative exponents. You did negative exponents in Algebra 1. Do y'all remember? No. That was a traumatic year, so it's okay. I'll teach them to you. So a to the minus m. See, I got a base and a negative exponent. All right, so here it's that little song. I like to move it, right? That's exactly right. You cannot, and we're going to write that in just a minute, but you move it. If it's on the top of the fraction, you move it to the bottom, and all it does is make your exponent positive. It doesn't change the sign of any kind of base. It only makes the exponent positive. If it's on the bottom of a fraction, you'll move it to the top, and that will make the exponent positive. So this one is where on the fraction, top or bottom? Top. Yeah, it's over a 1. Okay? So if I want to make it positive, where do I move it? To the bottom. And then there's nothing left on the top, so what do you have to write? 1 over. Y'all listen to me. That 1 is important. If you don't put him there, he's wrong. Okay? You move the whole thing down there and it makes my exponent positive. Y'all listen to me. This is a problem for some people. They don't put that 1. And that 1 says that you don't think there's a difference between $1 million and one millionth of a dollar. People, one millionth of a dollar won't buy you a kernel of popcorn. Okay? So, $1 million, and you got a lot of popcorn. All right? So, let's write this down. You can never, ever, ever, ever have a negative exponent in your answer. Have a negative exponent in your answer. If I see a negative exponent in the answer, I'm marking it wrong. No partial credit, I'm not looking at it, I don't really care. I said don't do it, so don't do it. All right, so here we go. Are you ready? Here's my first problem. 7 to the negative 2. 7 to the negative 2 power. What do you have to do? What? Take it to the bottom. And then it becomes 1 over 7 to the positive 2. And what is 7 squared? 49. 49. Okay? Oh, pull out my little blue pen here. Are you ready? You ready for this guy? He's trying to see, are you going to make a careless mistake? Okay? 2x to the minus 2, y to the third, z to the minus 6. All right? No negative exponents, guys. No negative exponents. So make all my exponents positive. Move it, move it, move it. All right, everybody got it?
I think so.
Okay, what's the first thing you did?
Put over 1. Put a 1 on top.
Put a 1 on top? I don't need a 1 on top. Yeah, why did the third's on the top? Okay, so I don't need a 1 on the top. What's the first thing you did? Did you make this exponent positive? What'd you pull down?
X squared.
Just the x squared. Okay, what power is the 2 raised to, guys? He's to the first power. So the common mistake is that kids think this 2x to the minus 2 is one thing. It's not. It's multiplied just like these other things. Okay, so the 2 is to the first power, so he stays at the top. The x squared moves down to the bottom. Okay, generally when you have more than one variable, how do you know what order to put them in?
Alphabetical.
Alphabetical order. Very good. Okay, what about this y to the third? Where does he go? On the top. What about this z to the minus 6? And he becomes a positive 6. All right, anybody got a question? Okay, very good. Moving right along. So, number 3. Nope, sorry. Huh? Y'all, look, I showed my other kids this too. You know how I always say I'm not good at numbering? These are my notes. I mean, they're like, I don't know, probably 6 years old or something. But anyway, 1, 2.
Yeah.
See?
But 3 is like the most
How did you qualify for this job?
I know. They couldn't find anybody.
There's no way.
They couldn't find anybody
It's the most
else.
important number though.
I don't know. I'm not good at numbering. So number 5 is a 0 exponent. 0 exponent. You're gonna love this guy, okay? Anything to the 0 power is what?
As long as it equals 1.
Yes.
Oh, it's one?
Yeah, it's 1.
It's 1. Anything to the 0 power. I'm gonna tell you why, but I'm gonna wait till after the next rule, okay?
One time I was in the class and she said.
No, it doesn't keep it whatever it is. It makes it 1.
No, it's fine.
Okay. Shh. This does have a restriction. A cannot be equal to 0. We know that 0 to any power is what? Don't just shout your answer out. Listen to what I said. 0 to any power is what?
0.
0. Okay, so obviously 0 to the 0 power, it doesn't work. You can't do that.
Right.
Okay? When I explain where this all comes from, after I teach you the next rule, then I'll go back here and do this. Okay, so let's try. I'm going to put 2 problems up here. Here's one of them. 2x y to the 5th, z to the 72nd, w m to the 11th, all raised to the 0 power. What's your answer?
1.
Boom!
Oh.
What? I'm going to put one on a test like that. People are going to miss it, and I'm going to laugh. Okay? That's ridiculous, people. Okay? Now let's see if you learned anything today. What about this guy? 2x to the 0 power.
It's 2.
It's 2.
Yes, very good. So it is 2 times, what is x to the 0 power? 1. And 2 times 1 is 2. Very good. Oh, I like that. All right, so here we
Wait,
go.
explain that one more time.
Come on.
Remember, it's kind of like this guy right here. This is 2 times x to the 0. And x to the 0, anything to the 0 power is 1. So it becomes 2
Okay.
times 1.
I see that.
Okay? All right. So number 6. Number 6 is quotient of powers. What does quotient mean? Division. Okay? Now y'all listen to me. Remember how I always tell you that math is logical? All right? What's the opposite of division? So when you multiply, you add your exponents.
So
Oh,
you subtract them.
yeah.
Obviously. I
Hello.
mean, come
I
on.
mean, it's very easy. So
Shoot.
a to the m over a to the n. Now, if I'm going to subtract them, who goes first? Yes, the top guy goes first. This guy right here, okay? This guy's negative. Comes up here. Oh, and he becomes a negative. Went up to the top. So take the base and subtract your exponents. All right? Now, I teach it a different way, so I'm going to show you both ways, okay? I teach it a different way because some kids I'll show you the one that they mess up on. All right, so I'm going to start off with a really difficult one. 8 to the negative 3rd over 8 to the negative 6th. Okay? So I'm going to use the rule. The rule says take the base. What's my base? And I subtract. Who goes first? Negative 3. The top guy goes first. So negative 3 minus a negative 6. What does that become? Positive 6. What's negative 3 plus 6? So 8 to the 3rd.
Wait, wouldn't you have to flip around that because you can't have a negative?
Okay, so I'm going to show you this. This is the way I would teach this problem. Okay, I would do what Lexi was talking about. I would make my exponents positive first. Okay, so this guy moves up to the top, and this guy moves down to the bottom. Okay, and then this is the way I teach it. I say, how many 8s? What's the most number of 8s that I can take out of this problem?
1.
3. Because y'all listen to me. First of all, 9. What in the world? Does he have 9? No. Okay?
I just
So
found something out.
you can only take 3 out because that's the most that this guy has. Now watch this. If I take 3 8s out here, aren't they all gone? What number's left down there?
1.
If I take 3 8s out here, how many am I left with?
3.
18.
16 blanks?
Yeah, if you add the 2 8s, you add stop.
Or you could just do
Stop.
6 minus 3.
Or you could do 6 minus 3. Okay? So why do I teach it that way? Here's why. Because here's where the problem comes in. When kids do problems like this, x to the 5th over x to the 7th.
And you have a negative and flip it.
That's exactly right. Kids go, oh, that's x squared. No, it's not x squared.
Negative.
It's x to the minus 2. But is that legal?
No.
What do you do with them to make him positive?
You want to raise.
So 1 over x squared. Whereas, if you do it like I said, and you take out 5 x's here, they're all gone, you're left with a 1. 5 x's here, and you're left with 2.
That seems a little easier.
Okay? So, it doesn't matter, they both work, so whichever way you like. Okay? Now, I want to go up here, and I'm going to show you why this is 1. I also want to tell you this. If you forget what it is, because sometimes on a test, do you kind of go, oh my gosh, I forgot. Yeah. So you could go, what is 5,287 to the 0 power? 1. I don't suggest you use variables in your calculator, but I did this time, just because it's the only time it will work. Okay?
Yeah.
So, but you could use your calculator to kind of make you feel better about yourself. All right, so let me ask you this question. What if I put x to the 4th over x to the 4th? What do you know that equals? 1. So from this rule down here, does it also equal x to the 4 minus 4?
So I'll give you 0, which is x.
And so, which is x to the 0? So what does x to the 0 have to be equal to?
1.
You see how that makes sense?
Well, that obviously works the
That's
same
so
thing over
appreciative.
That's exactly right.
So why would you have to do all that? You could just say it's
You don't. I'm just telling you why anything to the 0 power.
Let the teacher explain.
One. I'm just telling you why anything to the 0 power is 1. Last one. Last one. Are you ready?
Yes.
Cool, sounds like-
Did you say G?
Okay, so what is the last one? Powers of quotients. It's like this guy backwards. Powers
I was about to say, we just did that.
quotient.
What? I thought what?
Powers of quotients. Okay, so this means I'm going to have a quotient, A over B, something that's divided, and I'm going to raise it to a power. It's still going to be your logical thing to do. Everything in parentheses gets raised to that power. A to the m over B to the m. Very good.
Wait, but then if you want to.
You've done this before. You've done this one before. When we completed the square and you took half of something and you ended up with a fraction, and I said you square the fraction. How do you square it? You square the top and square the bottom.
Oh, yeah.
Okay? So I'm just going to work 1. 4/7 squared. 16 over 49. Very good. Now let me ask you something. Is this right here the same as this right here? Is this 4/7 squared? Now this is not 4/7. If you're squaring a fraction, what do you have to have? Parentheses. Okay? If you're raising a negative to a power, what do you have to have? Parentheses. Okay? So these are not the same things. You can't do it like that. All right, so let me show you the trick. Because y'all listen, this is what all happens. All right? You start working, because these are pieces of problems. But when I start putting things all together, and I start giving you problems that you have to multiply, and then you have to raise to powers, and you have negative exponents and 0 exponents, okay? And all kinds of stuff, all right? Then you need to know all these rules. So, this is the way my sister figured out how to make kids remember it, all right? So this is what you come to school with every day, or if you don't, you should, okay? A positive mental attitude during school, all right? It's not PEMDAS. The other kids all screamed out, PEMDAS. I'm like, that does not spell PEMDAS, okay? All right, so, but here's what it means. Powers to powers, what do you do with your exponents? Multiply. When you multiply, what do you do with your exponents? When you divide, what do you do with your exponents? Okay? So it's just a little acronym thing that I put on my paper, and then when I'm doing something, I can look back up there. Because it is weird that when you multiply, you add your exponents. When you raise a power to a power, you multiply the exponents. All right, so it's a little bit strange. Okay, so anybody got a question?
We're getting a worksheet tomorrow?
Yes, because I haven't worked, I really haven't worked any problems. I've worked pieces of problems, explaining the rules, but I haven't put things together.
This is not.
Okay? Now, before I start working any of those problems, I want to go over this with you for just a minute. I don't know how far we'll get. One class we didn't even get to it, and one class we got to it but didn't get finished with it.
15 minutes.
How'd you know that?
I looked at the clock and counted.
She looked at her phone. She also.
Scientific notation, okay? Scientific notation. Did y'all study scientific notation in chemistry?
Yes.
Okay, so yes. So this is scientific notation. A times 10 to the n power. A times 10 to the n power. Now, tell me what the restriction is on A.
Positive.
He has to be greater than or equal to 1 and less than 10. Greater than or equal to 1 and less than 10. Y'all, this is a mathematical technical way of saying I must have one digit to the left of the decimal point. Okay? One digit to the left of the decimal point. All right, so let's try some. Here's the first one we're going to try. 16,200,000. 16 million. Scientific notation is used to write extremely large numbers or extremely small numbers without having to write a bunch of zeros and stuff. Okay? So how would I write this number in scientific notation? What would A be?
1.62.
1.62 times 10 to the, and then you look up here and you go, how many times did I move my decimal point to make it be there? 3, 6, and one more. So times 10 to the 7. You got it?
Yep.
Okay, now I'm going to write a really small number, and I'm going to show you a friendly way to write a small number. Is it proper to put commas in these numbers with the decimal point? No, it is not. So, for those of us who have vision issues, okay, like I have Erlin syndrome. Have you ever heard of that? Okay, so like when I try to read stuff, it moves on the paper.
That's crazy.
Yes, it is. Like I can read a whole lot. Well, if you put a gray overlay, have you ever seen overlays? If you put a gray overlay over a magazine, I didn't know this, but I didn't know that like when y'all are reading a magazine, y'all can look away and then look back and look right to the place where you left. Oh, it'll take me 5 minutes to find my place. Okay, I have to almost read the whole thing again to find my place. But if you put a gray overlay, the first time they put that gray overlay, I was married, so I had to have been in my 30s. And so I like looked back and I was like, what? I said, I looked right back at the spot, and they all started laughing. And I was like, is that what y'all been doing the whole time? The whole entire life? And they're like, yes, yes. So it was weird. But this is the way we do it, okay? This is friendly. Do you see how friendly that is? If you put 10 zeros stuck together like this,
It's so hard to make count of that. You'll lose spot. Ones are
the difference between this and this is 5 minutes, this is 30 seconds. Do you understand? This is 5 minutes and a piece of paper, and I would have to do it more than one time. Okay? So, give me that courtesy. What's A? 4. Times 10 to the 3, 6, 9, 10, 11, right? And it's what? Negative 11. Very good. Negative 11. Okay, so I'm going to stop right there so we don't get too far ahead of other kids. But,
That means you're